some of the things that we started out from the beginning of the year. Okay, so we remember that we had a special formula. We had this formula that allowed us to convert from like a radical exponent, or if the base was a to the x over n power. So an exponent that is a fraction to a radical form, where the index is n, and your base is raised to the power of x inside of that exponent. And we have to realize, like, in order to solve these fully, that there's an operation that cancels these out, okay? So think about this. If we have an x squared, like x squared here, if we take the square root of x squared, it cancels. The square and the square root cancel each other and give us with x. Also, if you have the square root of x and we square that, they cancel each other and we're done. So look at this here, if you think about this, right? So if we take a look at this particular one, we have the square root of x squared. So if we were going to use our little formula that we had from the beginning of the year and transform this, right, we would end up having, well, the base we said was x, right? And we said, then we have a fraction, and the numerator of the fraction is what the radicand is being raised to, so that's a 2. And the index, which in this case it's a 2, is the denominator of that fraction. So x to the 2 over 2 power is x to the 1 power, which is just x. Okay, so that's why it's canceling. And the same thing over here, if you were to take, for example, if we had x to the 1/2 power, right, x to the 1/2 power, which is x square root of x, because it's raised to the power of 1 and the index is 2. You take this whole thing and we square it. Well, the power to power rule says multiply the exponent. So 1/2 times 2 is 1. That's how that also turns into an x there for you. So remember, these things aren't happening like magically. There's a reason why this happens, and we have to make sure we understand that when we go to the last couple of examples. I'm using a wireless mouse today, and it isn't wanting to cooperate as much. Let's reduce that size too. All right, so let's go ahead and get started with some of our stuff here, okay? So just like we did yesterday, we have to start to look at this and say, okay, the first thing we have to realize is, what are we solving for? We are trying to solve for g, and g is in this entire term here. So that means if we have our scales, we need to get rid of this c squared h. It's positive, so to get rid of it, we subtract it. So we subtract it. And then again, it's a lot of rewriting. That's what the theme of literal equations seems to be, is rewriting a whole lot of things. Yeah, this mouse is really giving me a hard time today. So again, rewrite, it's a lot of rewriting. And we keep going. Now if we look at this, we're still trying to solve for g, so g is not by itself yet. It's being multiplied by h, so to get rid of that, we have to divide both pieces by h. Our h's cancel, and we're left with a g equals 6 minus c squared times a capital H, and this whole thing here will be divided by the h. All right, not too bad. Notice this one here, they're having us solve for b, and what makes it hard is because they put a, it's not even that it makes it hard, it gives it the illusion of being hard. It's because they threw in an r to the 3rd power. But honestly, we're not solving for the r, so it's just a piece in a puzzle. It's like checkers, or it's just like, you know, chess. We're just moving a piece from one spot to another. So as we look at this one too, we should say, you know, we are here, we are trying to isolate this term by itself, because this is the term that has our b stuck in it. So the other stuff on this side of the equal sign is a W. It's positive, so we can subtract it. Again, these are not like terms, so like everything in literal equations, it's a lot of rewriting. And then we can bring down our b divided by r to the third power. Notice our b this time, it's trapped in a numerator. So in order to get rid of a fraction, or in this case, we just need to get rid of the denominator. We need to multiply by either the reciprocal. So if this is like 1 over r to the third, we're just going to multiply by r to the third. If we do it to one side, we have to do it to the other. This is the part that is important to kind of remember, guys, okay? If you are going to go and suddenly multiply something to the other side and there's more than one term on the other side, wrap that in parentheses, then multiply. I didn't carry this 3 all the way around here. All right, so now these cancel and we're left with b. b, and I'm not going to rewrite it again, b equals all of this. Notice the rule is that multiplication rule of equality says if you multiply one side, you have to multiply all the pieces on the other side. Well, instead of having to actually rewrite this dr to the third power minus wr to the third power, we just used our distributive property and represented it that way. Perfectly fine. So b equals d minus w times r to the third power. Here's one that starts to get interesting. Notice here we're solving for u, and u is stuck in a big term. There's several things going on here in this term. First thing we have to look at is, though, it is not by itself on that side of the equal sign. There's a c. So we have to subtract our c. We're left with d minus c equals, that's right, carry out all of this other stuff. Nah, you know what? I'm going to rewrite. I'm going to make this so we can see it maybe easier. Okay? They have 1/4 times. So 1 times UA is a UA divided by 4. This is going to make our next step much easier. All right? So now as we sit here and we look at this, okay, so I have UA divided by 4. So UA divided by 4. And I need U to be all by itself. That's what we're supposed to be solving for. So I have an A over 4 that I do not need here. So in order to get rid of a fraction, I can multiply by its reciprocal. So the reciprocal of A over 4 is 4 over A. These will cancel now and leave me with just a U. Well, if I multiply this side by 4 over A, wrap it in parentheses, I have to multiply this side by 4 over A. And then like that, U equals D minus C times 4 over A. All right, not a big deal. These are just, again, guys, it is just using our rules that we've learned, that addition, subtraction property of equality, multiplication, division property of equality, the distributive property to our advantage. And all those require you to be able to be good at reciprocals. Fractions are the ones that are sometimes the hardest. And then we have these here that are now going to include like this new symbol. So we're solving for A. Notice A is stuck inside of that square root. So the square root is like a grouping symbol. We have to tackle everything inside of it first, but we can't even do that because it's locked inside. So we need to get rid of it. And we talked about it up top was a square will cancel out a square root. So these cancel. If I square one side, I have to square the other side. We have an x squared equals capital A B minus C. Notice we are solving for A. So again, this is the term we're solving for. We have to get rid of the C. A lot of rewriting. X squared and C do not combine, so they just recopy. And these cancel. Now A is not by itself. We divide by B. The opposite of multiplication is division. And then here we go. These cancel, and I'm going to do that sneaky little trick. I'll switch colors so that it's more obvious. I don't want to rewrite it. I'm got a little lazy. It's okay. So A equals all of that. X squared plus C divided by B. Not so bad. Here we go here. We are trying to solve for G. Notice G is stuck in this term here, and G is also stuck inside of a square root or square. So let's not even worry about that to start with. Let's just start to isolate that term that contains the variable. Positive F, so the opposite is subtracting it. We're left with the 6 minus F equals HG squared. Great. Use orange. All right, so now as we start to look at this, look, that G is not by itself. It's being multiplied by H, so I want to get rid of the H. Now H divided by H cancels and leaves me with a G square. Now I have 6 minus F divided by H. Notice, here we go. This is where that rule from up top comes in. We have a square. Well, how do we get rid of a square? We are going to have to square root it. So in order to square root it, we take the square root of one side, take the square root of the other side, the square cancels the square root, and we're left with, and I'm gonna rewrite this in an interesting way, because if you have to type this into a computerized program, it can sometimes be difficult. So you're going to click the square root button first, then you have to type in the numerator. I will wrap that numerator in a set of parentheses. It makes it easier to do this operation, and it's solely about typing it into the computer. Then you'd hit the division button, and then you type in your H. And like that, this problem has totally been finished here. Again, we didn't do any fancy math with these. All we learned and had to remember was that a square cancels a square root, and a square root cancels a square, back and forth. So simply moving pieces, and that is all we have to do in this lesson here today, guys. All right, everyone, have a great time. Please get out there and do that homework.